everyone.
Good morning, Miranda. How are you?
I am doing very well. For anyone, I mean, I know that your name is on the plaque, but Francesca Lazzeri is joining us to teach us about machine learning and Python, just awesome stuff. And fun fact, you studied ballet for 12 years, right? We're
Yeah,
doing some
correct.
fun facts, which is like super cool. I'm
Yeah.
sure that you learned like so much through that experience. Yeah, I love learning like new things about people. So that's like crazy cool that you studied ballet for 12 years. That's awesome.
Yeah, this happened, many, many years ago when I was still living in Italy, and yes, I was into ballet, and probably I was really seeing myself also as a professional ballet dancer. But then, as you know, I started studying other things, and of course, data science, machine learning is one of those things, and then my career completely changed. But yeah, ballet is still, part of my hobbies, I would say. I don't practice ballet anymore, of course, but I go very often to see performances here. And we have the Opera House in Boston. I'm based in Boston, by the way. And so we have a lot of beautiful exhibitions. And so I'm very lucky. I'm following ballet as on the other side, as an audience, so that's a beautiful form of art, and it's really a combination of moving your body, but also the music is a very important component. So yeah, thank you, Miranda, for sharing that fun part.
I love you're so brilliant in like the data science and data realm, and I feel like it's just so awesome to learn more kind of about a person and their hobbies. So thank you for sharing that too.
Of course.
Yeah, and I guess we can jump right into the good stuff.
Yes, absolutely. Do you want me to share my screen? I can start
Yes.
with that.
Yeah, go ahead.
Perfect. So let me know if you can see it.
We got it.
And, okay, perfect. So as Miranda just said, I'm Francesca Lazzeri. I'm based in Boston. So if you're around in the Boston area in Massachusetts and you want to talk about machine learning, data science, time series, of course, let me know. I will be very, very happy, because I really think that this is a field where learning is a constant factor for all of us. And so I'm always looking for new ideas, new collaborators, and just, also sharing more of our experience in terms of the time series scenarios that we are trying to work on. So today, in this just 20-25 minutes, I will try to share a little bit more like a perspective on time series and time series forecasting, but more from a machine learning perspective. I work at Microsoft. I'm a principal data scientist manager at Microsoft. I lead now about 3 teams of data scientists, and we work, of course, with many different types of data. And one type of data that we have been working on a lot, of course, is time series data, because really time series data is everywhere. And so for me, it has been like a challenge at the beginning of my career to understand better what are the different algorithms, the different approaches that you can leverage in order to extract data from time series. So I will try to share a little bit more about my experience in this field and how I decided to leverage the time series also to learn more about my customers, the users, and also the different IoT data that sometimes we are leveraging, again, in my team, but also with external customers. So what I'm going to do today is I'm going to give you a introduction to time series forecasting from a machine learning perspective. And then I would also introduce a tool that is an open source tool that I have been using a lot, that is more useful in order to scale and accelerate machine learning solutions for time series forecasting. And that tool is called Automated Machine Learning. It's a Python tool. And so we will also see that in more detail. But first, I want to share with you this map. I know that it sounds and it looks very, very complex, convoluted, but it's actually a map that I personally created. I think it was back in 2012. And so I was trying to understand where is the data science machine learning journey starting? Where is really the moment in which you are trying to use data to solve problems? And so based on the different type of data that you have, based on the different type of problems that you're trying to solve, you can decide which is the algorithm family that you can leverage in order to solve those problems. And so I was looking really, I put together this map, and I was really looking at the different categories that we have them. And of course, I was also thinking that for time series forecasting, most of the time we use regression types of approaches. But we also have right now a lot of deep learning type of approaches, such as convolutional neural network, recurrent neural networks, that are actually working very well, especially if you have a large set of time series data. So this is actually where data scientists is starting their own journey with machine learning, data science, and time series data, as you can see. So, and this is probably the first category, the first family they are looking at, the regression one, I mean, when they are trying to understand how much or how many of something, of an item, for example, if we are in the sales scenario, like you try always to predict a specific number of sales. It can be like a product unit, it can be another quantity in the future. So this is probably the first category that you are going to try to leverage, category of algorithms in machine learning that you are going to try to leverage to predict something in the future. But first, also, let's look at a machine learning data set. And I always like to start with this very simple example that is, okay, this is a machine learning data set. And as you can see, is really a collection of observations. And time does not really play a role in a normal machine learning data set. And when I say normal machine learning data set, think about an image data set, think about a text data set. So predictions, of course, are also made with machine learning data sets for new data, but when this data is coming in, or when this data, for example, is collected, it's not really a big deal for a normal machine learning data set. For time series, actually, as you probably all of you know in this community, there is this additional time component, and that really adds a sort of dependence between different observations. And this is really a time dimension that you, as a data scientist, as a machine learning developer, you can, of course, see at it as a challenge. And I was looking at time series and this time dimension as a challenge at the beginning of my career as a data scientist, but it's actually also an opportunity, because it's an opportunity of extracting additional knowledge from your data. You have this additional time component, and you can understand better, for example, when a user was doing something on your website. You can actually create additional features, additional variables based on that time component. You can also look at additional information such as the stationarity in your data set. You can use additional information such as seasonality in your data set. And all of these additional information are actually representing variables that you can leverage in order to build more accurate machine learning models. Let's also be precise here, and let's also distinguish between time series analysis and time series forecasting. My background is actually in economics. So for me, when I started and I was at university and then through my PhD as well, I was really focusing a lot on time series analysis. That, as you can see, is really about understanding the historical time series data, and you try to understand better what are some of the patterns that are in your historical data, and you really are going to look at that to produce a specific analysis that are going to inform either your audience or yourself in order to conduct a specific research. What I really like of time series forecasting, and that's why I'm so passionate about it, is that there is actually this predictive component that is add on top of time series analysis, and you are using the insights that you got from your time series analysis in order to make predictions into the future. And so this is, again, another mindset shift that when you are a data scientist, you have to somehow to make in order to understand better, okay, not only I have this rich column of timestamps, time series data that can produce more insights, more data, more information for me. But I also have this opportunity now to predict something that is going to happen in the future. And of course, when I say future, there are many other concepts and terms that we have, such as the granularity of your data. You have to define the horizon, meaning how much in the future you're going to predict. But all of these, again, it's a sort of a mindset shift that you have to do in order to be successful in your time series forecasting predictions and the solutions. The third important concept that I always share with my data scientists, my students at university as well, is the fact that we need to look at the time series forecasting as a supervised learning problem. And through Python and through many other, honestly, tools that are out there for us, time series forecasting can be framed as a supervised learning problem. Again, this is not a new concept, but you need to understand how it is, how you can perform this process that is, by the way, called the sliding window, and how you can perform that both, I would say, on your data, even if you have a univariate, for example, scenario where you are trying to predict only one variable in the future, but this can be done also on multivariate scenarios where you have actually multiple variables that you want to predict in the future. So this is a very nice example here. I always try to start from simple concepts where you are actually leveraging your value number one, that is, you can see in this column, and you are using this to then create what we call in statistics, data science, machine learning, value X and value Y, that is the value that you want to predict. I was mentioning before also the multivariate scenario, but also in a multi-step supervised learning, you just need to perform the same type of transformation, and here you're looking at a time series data set, and you can transform that into time series as a multi-step supervised learning. I also want to give you like an overview of what are some of the Python libraries and packages that you can leverage for time series forecasting, especially when you want to apply machine learning to time series data. And honestly, there are a lot of very advanced frameworks out there for time series forecasting. We're going to see one of them today together, automated machine learning. But also, if you look at the basic libraries for Python, there are so many, and here again I try to summarize some of them. If you start from SciPy, that is this ecosystem of Python libraries, you have NumPy, Matplotlib, Pandas, Stat Models, Scikit-learn. Usually when I teach these packages, I always divide them, as you can see, in two categories. There is the libraries that provide the foundation for most others libraries, and then there are the other three on the right that are more like a high-level SAPI library that provide key features for time series. So honestly, you have a lot of tools out there that are very, very helpful when you really need to build the models, actually build, train, and test, evaluate your models for time series. And when I say models, I mean machine learning models. I think that right now, probably one of the biggest challenges that we have in the industry, in the machine learning industry, and specifically the field of time series forecasting, is really about scaling solutions, time series forecasting solutions in a sustainable way. And of course, there is all the field right now of MLOps, so machine learning operations, machine learning model governance, that are somehow trying to drive this type of conversation on how we can build models that then can be deployed and can be operationalized and also consume over time in a sustainable way. So that is extremely important, because we can spend hours, months, years building beautiful time series forecasting models in Python, in other tools, but then how about the operationalization part? How we can make sure that these models are deployed and are consumed by our customers, by the community, in order to make sure that we have a predictive solution that are actually predicting something that is useful for us. So that is the biggest, I would say, challenge that we have right now in the industry. That's why today I also wanted to talk about some of the frameworks that I have been using from a machine learning point of view, of course, in my everyday work. And one of the tools that I think is bringing the industry to build a solution that are scalable and sustainable is probably automated machine learning. What is nice of automated machine learning is that it doesn't replace data scientists, because a lot of people, every time that I introduce automated machine learning, and by the way, I have been working a lot with the research team at Microsoft, and then also with some of the product teams at Microsoft that have been developing this tool, and this, by the way, open source tool. A lot of people ask me, okay, but is automated machine learning going to replace data scientists? I don't really think so. I think more that automated machine learning is just an additional tool that the data scientists can leverage when they think about end-to-end time series forecasting solutions. So quickly, just to give you an overview, what does automated machine learning in Python? It identifies the best list of models, of algorithms for you, based of course on the data set that you're using, based on the problem that you're trying to solve, and based also on the amount of data that you have, and it is trying to to identify the best model, and it does that in different ways, and also by performing what we call the hyperparameter tuning, the featureization part, the model interpretability part. So these are all little tools, not really little, because they're actually pretty important tools, but that are helping data scientists to accelerate the machine learning development cycle, and then, as a consequence, the deployment cycle of machine learning models. I also created a demo for this. So what I'm going to show you in the next few slides is actually based on a data set that is about energy demand. So in this data set, what I try to do is predict next hour of energy consumption in a specific geographical region. For this, it's a public data set, so I use the New York region. So you can see how much energy is going to be consumed at the hour level. So the granularity of the data is hourly for the next hour, for the next 6 hours. So next hour is the prediction, horizon is equal to 6. The goal of this scenario is really about predicting energy demand, and also understanding what are the different tools, the different components in automated machine learning that you can use for your time series analysis, not just related to energy. Honestly, you can use a different type of data, but as long as, of course, it is time series data. So here I put a screenshot. I don't know if you can see it, but again, I will share again the GitHub repo so you can try that also offline. But here I also created this table on the notebook where you can see that you still have a total control on what automated machine learning is doing for you, especially if you use, of course, the Python version. And here what it's doing is that, of course, for a task, you have to specify that you are in a forecasting scenario, the primary metric that you are going to use in order to evaluate your models. Block models, these are the models that you already know you don't want to include in your time series forecasting solution, because it can be models that you have already tried or other data scientists in your team have already tried and you don't want to use them. And then some additional information that you have to input, such as the training data set, the label column name, the number of cross-validation. This is the number of cross-validation splits, and then how, if or not you want to enable the early stopping, and what are your forecasting parameters. So here, as you can see from this table, I'm basically translating everything in Python here in this first cell. And basically you just need to specify these parameters, these requirements in Python. For example, here, as an example, I selected as a block models, extreme random tree, outer rim, and profit, because I had 3 parallel experiments where I was already trying those 3 algorithms, and I didn't want automated machine learning to include them. In terms of the machine learning data requirements that we would need to look at in order to use automated machine learning, there you can use either tabular or flat data. And in terms of sources, you have the option of using local upload, blob, data lake, Azure SQL database, any other also SQL database. And so this is a very flexible, I would say, in terms of where your data is and how you can access them, and just bring back the data into your Jupyter notebook if you're using a Jupyter notebook for Python or any other software that you're using in order to leverage this Python package. And then in terms of forecasting functionality, there is, we will see together, like most of the time when you are a machine learning scientist and you're looking at time series data, you're looking for specific functionalities, such as, of course, you want to look at the seasonality of your data, holidays and fact, the deep learning models that you can leverage, as I was mentioning at the beginning when I showed the map that I created with the different approaches. Usually you start with simple regression approaches, but then you know that there are some other more advanced approaches that you can try, of course, based on your scenario and based on the amount of data that you have. And then also other frameworks such as a Prophet, and also there is the option of using multiple time series. So these are most of the time the forecasting functionalities that you're looking at when you start coding your solution for your time series data. So in terms of featureization, let's quickly look at featureization, model selection, model training, and then forecast. These are the 4 steps that I always look at when I need to perform a time series analysis and I need to build a time series forecasting solution. Featureization, let's start quickly with this. There are many different techniques, of course, that you can use, such as deep learning based type of techniques, custom featureization in case you want to create your own features based on the timestamp column that you have in your data. You can, of course, automatically create these features using the featureization option in automated machine learning. And then there is also a sort of a pre-processing part that automated machine learning is doing for you. So in terms of pre-processing, for example, if there are missing values, if there are outliers, if you need to decompose dates to year, day of the week, day of the month, that is usually the classical featureization process that you apply to your time series data, but also others, such as if you want to add a seasonal and trend component, which are very important. And then you can also build the look-back features, such as lags and rolling windows. In terms of look-back features that I usually build all the time, because I found them very, very helpful, especially in time series scenarios. Usually I build target lags, and then I start building feature lags, and then of course I always add what we call the target rolling windows. Then after that, you have prepared your time series data, so you have all these additional features, variables that you wanted to consume and to include in your model. Of course, there is the model selection part. Here, what is nice, as I said before, is that of course you can select the types of models that you want AutoML to perform for you. In general, automated machine learning allows what we call this automatic splitting of training set into training and validation. And this validation part is used to select the best performing model for your, again, scenarios and for your specific data set. After that, you can start with the training. The training part, I would say, is probably the most exciting one, because you are looking at the different machine learning pipelines that are running in parallel. So for this specific part that we have also the, I try again to summarize in this slide, we are going to try regression models, but also classical models. So classical models are most of the time from the ARIMA family. This stands for Autoregression Integrated Moving Average, which is a really, really nice model that you can use for your time series data. But then there are also more advanced frameworks, open source frameworks, such as Prophet is one of those. Etna is another one that we have been using a lot. And finally, you can also decide if you want to use some of those DNN model, deep neural networks models. Some of those, as I mentioned, are, for example, the recurrent neural networks, especially LSTM, such as long-term short memory, and also convolutional neural networks are actually very, very powerful when you have a large data set of time series values. I will leave here. I know that we are timed. The last slide that I want to really to present today is about this end-to-end solution. So my advice for data scientists that are trying to leverage time series data is really about first spend enough time looking at your data, trying to understand how you can extract as much information as possible from your time dimension. That is the key, honestly, when you work in time series data. Try to build additional features using different tools. One of these tools, of course, that I share today is Python, and there are many open source libraries because that is the tool that I have been using. And after that, really start to think not just about the machine learning model that you're going to build, but also about what are going to be the results that you want this model to produce for you, for your customers, and how you can make sure that you have a sustainable, scalable solution that then is going to be consumed over time by also other users, other customers, and are really trying to get the best out of the machine learning solutions that you build. I hope you enjoyed this short conclusion. Of course, if you wanted to learn more, there is also this book that I wrote on machine learning for time series forecasting with Python. I put here some links, but probably the most interesting link for this presentation today is this GitHub link, where you can find the energy demand forecasting demo and solutions that I build using Python, and also different AutoML solutions. Thank you very much. It was just a pleasure being here. Thank you, Miranda.
Yeah, thank you so much for coming to do this talk. This was absolutely brilliant. I know that I learned a lot, and yeah, I'm super excited to look more into the automated machine learning tools that your team has been working on, because that also sounds very powerful, which is super cool. We do have one question from a user, and I guess it's really two questions, but since we're short on time, we'll probably only ask one. But their first question was, what are the typical steps that you take to kind of shape your data to get it ready for machine learning?
Very good. And I love this question because as you saw from my presentation, I try really to summarize the different steps that you should follow, especially when you are working in machine learning with the time series data. And I really think that spending time on the data exploration, data preprocessing is extremely important. So the first few steps, I would say, always look at your data and try to detect, of course, if there are missing values, outliers, if there are specific cycles. Seasonality is one of these. Let's think about energy consumption from the example that I have been using in this presentation today. Of course, when it is a summer, there's going to be probably a lower consumption of energy. In the winter, probably there's going to be a little bit more, or like there are going to be some differences between the day and night. For example, these are just some hypotheses. So always trying to understand what your data is telling you in terms of trends, seasonality, missing data, outliers. And then the second step is really about also looking at stationarity in your data, because that is the key point also for time series data and time series analysis in general, because based on the stationarity level that you're going to find out, of course, you will need to decide what are the different algorithms from the classical family or from the deep learning, more advanced approaches, like as I mentioned, some of them, LSTM, GRU, convolutional neural networks that you can apply. So these are, I would say, the first few steps that I would do, and then the other part that is probably one of the most fascinating part of time series is really about start building those features that are the key to include this type of information in your machine learning models. Those features are usually time-based type of features, such as day of the week, time of the day, it is an holiday or it's not an holiday. Of course, the geographical component is extremely important because holidays can change depending on where you are. And so like there are so many additional information, lag features that I was trying to introduce today. So there are so many additional information that you can extract, and then you can include this information in your models. And always remember that you are going to train the model. So the more information you're going to input in the model, the better it is, especially at the beginning when you are experimenting. And then, of course, you are going to select those features that really have a predictive power within your machine learning solution. So this is my recommendation. I know it's a long answer, but yeah, this is usually the process that I follow when I work with time series data.
Yeah, it's super helpful. I know, like, I mean, I've only kind of taken small steps into the like time series analysis and like with machine learning, and even just hearing that, it's like, yeah, super helpful and awesome. Thank you. And I am curious, I know that you had a link to your GitHub repo for kind of running through the example. Is there also a way that we, the maps that you had, is there a way that we can like see those again? Because it had so much awesome information. I was just curious myself.
Of course, thank you for asking this question. I can just share the entire slide deck, so you're going to find the GitHub repo, the map. That is really a map that was taken from my notes. So, but it can be useful also for other data scientists, and so I will just share the entire slide deck with you.
Oh, wonderful. Awesome. Thank you so much again for coming and speaking. This was absolutely brilliant.
It was just a pleasure. Thank you.
Thank you.